Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter electric charges and fields. So if you have any questions regarding any steps of the solutions or any other kinds of doubts if you have, then please write us in the comment section. We shall clarify them in the subsequent videos. And if you feel more difficulty in any of the chapters of physics, then also please mention the name of that chapter in the comments section. Then we shall give more priority on it and solve more and more questions on that chapter, which shall be helpful for your KCET exam. Also, the homeworks on every chapter will be uploaded in the Sapience education application. uh, so please install our Sapience education application, whose link has been provided in the description. So here we shall solve from the question number 1. Here it is told a Gaussian sphere encloses an electric dipole within it. The total flux across the sphere. So one sphere is there and inside it one dipole is included. So an electric dipole means it consists of a pair of charges, and those two charges are equal and opposite charges. One is minus q and one is plus q, and they are separated by some distance d. So this is called as an electric dipole. So the total charge in an electric dipole, that is always 0. The total charge in an electric dipole is always 0, since why it is minus q plus q. So if we add them, then we will get 0. So it means that then we know that the total flux, the net flux across this sphere, that is given as q enclosed by epsilon naught, which is according to the Gauss law. So here the total charge enclosed by the sphere, that is equal to 0 if we have an electric dipole within it. So hence the net flux or the total flux across the sphere will be 0. So option A is the correct answer. Then here it is told that a comb run through one's dry hair attracts small bits of paper. This is due to. So a comb is run through one's dry hair attracts small bits of paper. This is due to. Okay. So since that is the atoms in the paper gets polarized by the charged comb through one's dry hair. Okay. So here attract small bits of paper. So when the comb is run through dry hair, then some static electric charges are formed on the comb. Some static charges are there. Some static charges are formed on the comb when it is rubbed through the dry hair. So then the bits of paper, the bits of paper is acting like a dielectric substance. It is acting like a dielectric substance. So when the charged comb is kept in front of it, then some electric field is acting on the bits of paper. So so the atoms in the paper will get polarized. The atoms in the paper will get polarized. So when a dielectric substance is brought in front of some external electric field, then we have something called as electric polarization. Electric polarization is there. So hence the options and hence the net electric field inside the dielectric substance is decreased. The net electric field in the dielectric substance is reduced due to this electric polarization. So option C is the correct answer. Then in question number 3 it is told a simple pendulum has a length L. Simple pendulum is there, it is having a length L, and the mass of the bob is M. Mass of the bob is M, and the bob is given a charge Q coulombs. The pendulum is suspended in between the vertical plates of a charged parallel plate capacitor. If E is the electric field strength in between the plates, the time period of the pendulum is given by this. So here we have an electric field in between the plates of a parallel plate capacitor. So it means that here in the equilibrium, so the equilibrium position of this pendulum will be slightly at some angle with the vertical. The equilibrium position of this simple pendulum will be at some angle with respect to this vertical. So let that angle will be theta. So here we have mg acting downwards, and here we have QE which is acting horizontally. So therefore the net force will come, that is mg square root of mg whole square plus QE whole square. So therefore the time period of the pendulum will be given as 2 pi root over L by G effective. So we have to find the G effective. So the net force, we can say the net force on the bob of the pendulum, that is equal to mg, that is equal to m into G effective. So that is equal to square root of mg whole square plus QE whole square. So therefore we can say that G effective, that will be equal to this will be G square plus m square will get cancelled, so this is QE by m whole square. So G effective is this, therefore the time period of the pendulum will come 2 pi root under L by square root of G square plus QE by m whole square. So option D is the correct answer. So if you are unable to understand any of the solution steps, or if you have any other kinds of doubts, please write us in the comment section. In question number 4 it is told that two identical charges repel each other with a force equal to 10 milligram weight. Identical charges repel each other. Identical charges, there if their charges are equal, they repel each other. The force equal to 10 milligram weight means, and G is equal to 10 meter per second square. So 10 milligram means 10 into 10 power minus 3 gram. So gram means it is into 10 power minus 3 kilogram. So this much kilogram weight. So it means it is m into G. So the force is 10 into 10 power minus 6 into G, that is 10. This much Newton. So this is 10 square into 10 power minus 6, that is 10 power minus 4 Newton. So by this force they are repelling each other. They are repelling each other with this much of force. When they are 0.6 meter apart in air, they are 0.6 meter apart in air, 0.6 meter apart in air, then the value of each charge is, when they are 0.6 meter apart in the air, this is air, the value of each charge. So they are 0.6 meter apart, so therefore the force is given by the Coulomb's law. The electrostatic force of repulsion will be kq1 q2 by, so kq square by r square. Here r is 0.6 meter and q, we have to find the value of the charge, and k is given as 9 into 10 power 9 Newton meter square per coulomb square. So therefore this force is same as this 10 power minus 4. Therefore 9 into 10 power 9 into q square divided by r square, which is 0.6 whole square, that is equal to 10 power minus 4. Then we have to find out the value of q. So this is q square into 9 into 10 power 9 divided by, this is 6 square into 10 power minus 2 is equal to 10 power minus 4. So therefore we can say this is 9 4s are 36. So then q square will be equal to 4 into 10 power minus 2 into 10 power minus 4 divided by 10 power 9. So q square will be equal to 4 into 10 power minus 6 minus 9. 9, so this is milligram weight. Into 10 power minus 6 minus 9. So q will be equal to 2 into 10 power minus 15. So this is, so if I take this as, this is milligram, so we should take it as gram weight. Actually this should be gram weight. So this will be then 10 power minus 3 into 10. Okay, so this will be then 10 power minus 1 Newton. So 10 power minus 1 then. So minus 3 minus 9, this is 10 power minus 12. Then this will be 2 into 10 power minus 6 coulomb. So this will be 2 microcoulomb. So option D is the correct answer. Then here it is told, question 5, that alpha particle, and alpha particle of mass, its mass is 6.4 into 10 power minus 27 kg, and the charge of the alpha particle is 3.2 into 10 power minus 19 coulomb, is situated in an uniform electric field. It is situated in an uniform electric field of 1.6 into 10 power 5 volts per meter. The velocity of the particle at the end of 2 into 10 power minus 2 meter path when it starts from rest, that is how much. So here the electric field is constant, so I can say the force, the electric force, that is q into E, that is also constant. So when force is constant, it means that the acceleration is also constant. Means force equal to mass into acceleration. So acceleration, I can say that is F by m, that is equal to QE by m, that is also constant. So when there is constant acceleration, then we can apply the equations of motion. We can apply the equations under uniform motion. So uniformly accelerated motion it is. So therefore I can say v square equal to u square plus 2as. We have to find the velocity at the end of this 2 into 10 power minus 2 meter path, and it is starting from rest, so u equal to 0, and the displacement is 2 into 10 power minus 2 meter, and acceleration is this. So therefore v will be equal to root over 2a into s, where a is this. So this will be 2 root over 2 qes by m. So therefore here v will be equal to root over 2 q is 3.2 power minus 16 into minus 19, 3.2 into 10 power minus 19 into e, that is 1.6 into 10 power 5, 1.6 into 10 power 5 into q, 2 qes. S is the displacement, s is 2 into 10 power minus 2 to 10 power minus 2 meter, 2 qes divided by m. M is 6.4 into 10 power minus 27, 6.4 into 10 power minus 27, this much in meter per second. Rest, okay. So this will be equal to, v will be equal to the square root of 2 into 3.2, that is 6.4, and 1.6 into 2, that is 3.2 again, into that is 10 power minus 19 plus 5 minus 2 plus 27, this much meter per second. So this will be equal to, this is divided by 6.4. Okay, so divided by 6.4, so 6.4 and 6.4 will cancel out, so then we will have square root of, this is 32 into 10 power minus 1, so this is 10 power minus 19 minus 1 plus 5 minus 2 plus 27, this much meter per second. So this will be square root of 32 into 10 power minus 20 minus 20 minus 22, so minus 22 plus 27, that is 5, 5 plus 5 is 10, 10 power 10 meter per second. So this is 4, it's 16 to the 32, so it is 4 root 2, 4 root 2 into 10 power 5 meter per second. So it is option D. Option D is the correct answer. Then it is told that two identical conducting balls A and B have positive charges Q1 and Q2 respectively, but two identical conducting balls A and B have positive charges Q1 and Q2 respectively, but Q1 is not equal to Q2. The balls are brought together so that they touch each other. They will touch each other and then kept in their original positions. The force between them is identical conducting balls. So when they are kept in contact, then their charges are redistributed. Their charges are redistributed. So then here force between them is less than the less than that before the balls touched. Okay, so when they are touching each other, two identical conducting balls, identical means their radiuses are same. Their radiuses are r, suppose. The radiuses are capital R. So then here the force will be when they are kept in contact, their charges are redistributed, and each will have the same charge q dash. So this will be q1 plus q2 by 2. Then the force of repulsion in between them, that will be equal to k q dash square, k q dash into q dash by r square. R square is 2r whole square. So it means that after they are kept in contact, they are again kept in their original positions. So here again their distance of separation will be r only, and then here they have charges q dash and q dash. Then here the force will be k q dash whole square by r square. So this will be k by r square into q1 plus q2 by 2 whole square, which is k q1 plus q2 whole square by 4r square. And then initially the force of repulsion, that was means uh, before they were brought in contact, the force of repulsion in between the two conducting balls, that will be k q1 into q2 by r square. Now this is equal to, we can say this is k by r square into this will be, this is k by 4r square, this will be q1 square plus q2 square plus 2q1 q2. So this we can also write, this is q1 plus q2 whole square. We can write it as q1 minus q2 whole square plus 4q1 q2. So we can say that k by 4r square into q1 plus q2 whole square. So that will be equal to k by 4r square into q1 minus q2 whole square plus k q1 q2 by r square. So it means that this is higher. So the force, the new force after their charges are redistributed, after the redistribution of charges, uh, after they are uh, come after they are brought together, that is higher. It means that the force in between them after they are being touched is greater than the force in between them before they are being touched. So f dash is greater than f. And after they are kept in contact, after they are being touched with each other, then their charges will be q1 plus q2 by 2, q1 plus q2 by 2. Since why? Since they are both conductors, the potential should be the same. Means we should tell that, like, after they are after they come into contact, so initially they were q1 and q2, then afterwards that is q dash and q dash. So at the center here, the potential should be the same. The potential should be the electric potential should be same here and here. They are kept in contact. Then is that kq dash. Okay, so it means that, and charges are, it means that the total charge is always conserved. Total charge is conserved. Here if it is q1 dash, it is q2 dash, then we can say that k q2 dash, this distance from the center is 2r, so k q2 dash by 2r. So the total charge is conserved. So it means that q1 plus q2, that should be equal to q2 q dash. So it means that q dash should be equal to q1 plus q2 by 2. Okay. So it means that the new force, the force after the, means the force in between them is greater than that before the balls touched. It means that option B is the correct answer. Then here it is told, two identical charged spheres of material density rho suspended from the same point by inextensible strings of equal length make an angle theta in between the strings. Two identical charged spheres of material density rho suspended from the same point by inextensible strings. Make an angle theta between the strings. They are being suspended by equal strings, two identical charged spheres. Their material density is low. They are identical also, it means their radiuses are also same. Radius is r. Suspended from the same point by inextensible strings of equal length. Suspended by strings of equal length. Make an angle theta in between the strings. When suspended in a liquid of density sigma, the angle theta remains the same. The dielectric constant K of the liquid is. So their distance of separation, their length is L, the length of the string is L, then their distance of separation will be L sine theta. L sine theta, so this will be 2L sine theta. And they are having some identical charge spheres of material density. They are having charge Q and Q. Therefore, we can say that the angle theta by 2 is mg. And this is the force means I can say this is mg sine theta by 2. Mg sine theta by 2, that is equal to this. This is angle theta by 2. This is mg sine theta by 2. And this is 90 minus theta by 2. So this is again theta by 2. This is f cos theta by 2. So mg sine theta by 2, since it is in equilibrium, so mg sine theta by 2 should be equal to f cos theta by 2. Therefore, I can say that tan theta by 2, that is equal to f by mg. The force is equal to kq square by r square, which is 2l sine theta whole square. Is equal to 1 by 4 pi epsilon naught q square by 4l square sine square theta. And mass, we can write it as density rho into volume. Density into volume of the sphere. It means that if theta has to remain constant, it means that the ratio of f and mg should remain constant. So from here, you can say that tan theta by 2 is equal to f, which is 1 by 4 pi epsilon naught into q square by 4l square sine square theta f by mg. So here also into 1 by mg will come, which is rho into v. Therefore, you can see that tan theta by 2 into sine square theta, that is equal to q square by 16 pi epsilon naught L square by epsilon naught L square into rho v into g. Now, when it is kept in the liquid, when this is suspended in a liquid of density sigma, angle theta is remaining the same. So then the net downward force, instead of mg, I should tell mg minus v sigma g, since one upthrust will also be acting, and this is the force, which is equal to q square by 4 pi epsilon naught into k into r square, which is 2l sine theta whole square, which is 4l square sine square theta. So then also the angle is remaining the same, which is theta by 2. Therefore, you can say that tan theta by 2 into that will be again equal to 1 by 4 pi epsilon naught into k, where k is the dielectric constant of this liquid, into this is q square by 16, q square by this is 4l square sine square theta to 1 by this mg, but instead of mg I should write v into rho minus sigma into g, since it is mg minus v rho g, v sigma g. This is by v into rho minus sigma into g. It means what? From here we can see that tan theta by 2 sine square theta, that is also coming equal to q square by 16 pi epsilon naught l square v into rho minus sigma into g into k. So here we have got, so these two angles are coming the same, so it means that these two expressions also should be the same. So therefore we can say that from here v into rho minus sigma into g into k, this term, these terms are the same, so this term should be equal to v rho into g. So this v and v will cancel, g and g will cancel, so therefore we can say that k is equal to rho by rho minus sigma. So option A is the correct answer. So here we shall end the first part of this video on the chapter electric charges and fields. So hope you have understood these 8 questions, and in the next part of this video on electric charges and fields we shall solve the remaining questions on this chapter on the previous year KCET questions. So if you're unable to understand any of the solutions, then please write us in the comments section, and please install our Sapience education application, whose link has been provided, where we shall upload some important homework questions on this chapter. So thank you everyone.